Right, so in question 3, we note that we have two parallel lines. So ST and VOU, these are parallel. And because of that, we may be using the alternate angle rule here. So we could say that angle, or ST, is parallel to VU. So these are parallel. Okay, so I'm just taking a note that these two lines are parallel. And note also that TOU is 66. So I'll just note that. So angle TOU is 66 degrees. So this angle 66 can be used to calculate this angle here. So we've got angle at center is 2 times angle at circumference. So angle at the center is 66. So this angle is 66 is 2 times angle at the circumference. So let's just clear that and just take note of that. So angle at the center here is going to be 2 times the angle at the circumference, and we recognize this shape here. So angle at the circumference is going to be X because these angles will be equal. So 2X. So in this case, X will be 33 degrees. So we should also make note here that angle STV is equal to angle TVU. And that's the alternate angle rule. Okay, so we got XN. It's basically going to be half of 66. So this is 33, which ultimately means that that angle is 33 there. Okay, so that's your answer for question 3. Okay, so in question 4, we have 2 values to find. We've got X and Y to find. We know that this angle is 128 and this angle is 32. And one thing to assume is that these angles are the same. Do not assume that, because these may not be equal. Okay, so that's one mistake that some students may make. And if I demonstrate that by redrawing the picture, imagine the line comes from here to here. So X is moved around here. So we can see obviously that this angle is not going to be the same as this angle. They're quite different. Okay, so don't assume that these two angles in the corner are equal. They may be equal, but in most cases, they may not be equal. So be careful with that. So the first rule that we can see is that the angle at the center is going to be 2 times the angle at the circumference. This will find X. So angle at center equals 2 times angle at circumference. So the angle at the center we know is 128, which is 2 times the angle at the circumference, which is X. So X would be 128 divided by 2, which is 64 degrees. So we know now that this angle up here is 64. Now what you see here, we actually have a quadrilateral. This line, this line, this line, this line. So this is a quadrilateral, and a quadrilateral is just any 4-sided shape made by using straight lines. So this is a quadrilateral. And what we know about quadrilaterals is that the angles will add up to 360. So the sum of angles equals 360. So we know this one, we know 64, we know 32, but now we need to know this angle here, which is going to be 360 360 minus 128, which will give you 232 degrees. So this is 232. So if we add these four angles here, we should get 360, okay? So we'll add them up. So we have y plus 64 plus 32 plus 232. And we should get 360 as the sum of those angles. When you rearrange that, you'll get y equals 32 by moving these numbers to the other side and subtracting. So your answer is actually indeed 32, but as I mentioned, that's not always going to be the case. And x will be 64. So in question 5 here, excuse me. So in question 5, we have a familiar shape inside our circle. And as we can see from the previous example, we can't assume that these angles are going to be equal. Okay, so that's one thing to bear in mind. Now, it looks a bit complicated, but what I recommend you do is separate this shape into two isosceles triangles like that. So quite often this is the best approach. Separate your quadrilaterals into triangles that you can work with. And when you do that, you've actually created two isosceles triangles, one here and EOF, this one here. So as we know, the base angles of the isosceles triangles are equal. So if this is 35, this angle up here is also 35 in here. And this angle is 21, which means that this angle up here is also 21 degrees. So we should actually take note of that. So we can say that angle EDO is equal to angle DEO, which equals 21 degrees. So you should take note of what you're doing here. So don't just give me the total angle, but actually separate it and show the working. And that is base angles of an isosceles triangle. And we say the same for this one. So here, OFE or EFO, we'll do that. EFO equals angle FEO. And they both equal 35 degrees. And that's, again, base angle of an isosceles triangle. Okay, so now we can do the sum. We can add these angles to get our first answer. So for DEF, it would be 21 plus 35 degrees equals 56 degrees. Okay, so this total angle here is 56. So for angle DOF, which is this angle here, the angle outside the shape, now that will be twice the green angle here, twice of 56. So we should write our rule. So angle at the center equals 2 times angle at the circumference. So angle at the center, we don't know. So that's angle DOF is 2 times the angle at the circumference, which is this angle here, DEF, which will be 56. So then you get 112 degrees for your final answer here for angle DOF. That one there. Okay, in question 6, we need to find this angle X down here. And the first thing to note is that you have parallel lines here. Okay, this is one thing to note. So we may be using our alternate angle rule here. So from this rule, we know that this angle is going to be equal to this angle here. And that might be quite useful to find x here. So you can imagine if we know this angle, we can find x because the sum of those three angles will be 180. But the first thing to note is that this pattern here where you've got angle 84 at the center, and then you have this line coming down here. So you recognize this shape is just upside down from what you've been seeing before. So we can calculate this angle from the 84. So we'd write angle at the center is 2 times angle at the circumference, which is this angle down here. So the angle at the center is 84, is 2 times the angle down here. Let's call that EGF. So angle EGF would be 84 on 2, which would be 42 degrees. So this angle down here is going to be 42. Okay, and then by the alternate angle rule I just mentioned earlier, this angle is also going to be 42. So we could say angle EGF will be equal to angle GED. And that's by the alternate angle rule. So this angle up here is 42. So they both equal 42 degrees. So if this is 42, this is X and this is 38, you can see you've got angles in a triangle now. So you've got a triangle here, and the sum of those three angles is going to equal 180, isn't it? So we could write X plus 42 plus 38 will be equal to 180. So X is 180 minus the sum of those two angles, 42 plus 38. And when you do that, you'll get X equals 100 degrees. And that's your required answer for this angle here.